All right. Hey, what's up, guys? Happy Tuesday. Beautiful day outside again today. A little chilly out there, but I'm being warmed up by my morning coffee. And what's one better way for a geometry teacher to start their Monday or start their early morning? It's a Tuesday today, than to do some geometry. So that's why I'm going to start my day today with you guys here. Okay. So you got here the section 3-1 problem set. You did the exit ticket yesterday. I've gotten feedback back to fifth block. Haven't gotten feedback back to third block, but I will do that very soon right after this. So hopefully you got some guidance on this. You're going to spend some time with congruent figures today. And it looks like we have some congruent triangles right there. Awesome. So corresponding parts of congruent triangles are congruent. CPCTC. Stay awakened. Anyways, so you got your problem set today. You're not going to see me again until Friday. So I hope you do watch this video because I'm going to do some examples for you just to get you started. I anticipate these problems on the homework being a little bit more confusing than maybe some of the other problems you have. So that's why I want to do them with you. But just actually a quick reminder again, too, I have this spreadsheet where I'm putting up all the homework, all the vocabulary, everything that we've done. It's all being tracked here. So I highly recommend you're looking at this every day. I know you can be looking at Google Classroom too, but it might just be nice to have the whole schedule in front of you. Here are all the problems. So I'm not going to go over, oops, it is right here. Yes, this is it. I'm not going to go over all the problems. Like I'm not going to go over number 6 through 12 for the classroom exercises. Although I'll go through 10, 11, and 12. I'm not going to go through 18. I'm going to go through 21. But so notice here, there are a whole bunch of other problems. I anticipate this problem set taking you about 45 minutes or so. 15 minutes on the classroom exercises, 30 minutes on the written exercises. So just be focused. Try to flex your thinking caps and your brain power here, and I think you'll be fine. We'll go over these on Friday during a Jamboard, okay? During a Jamboard here. It's not going to go into Friday, but I still want you to do them today, and you got to turn it in by Thursday morning because you'll actually do the lesson for section 3-2 on Thursday. Anyways, let's jump into it so that you don't have to be on this video super long here. I'm going to go through the few examples. Again, these are the ones that we're going to do right here. We're going to do these classroom exercises, and then we're going to do these written exercises, okay? So only a few of the problems here. These two triangles are congruent, complete. Very nice, okay? So what are they given to us? Given premise, this triangle here is congruent to that triangle. Lovely, lovely. That's very nice here. So we know that congruent triangles or congruent figures at all, right? Well, congruent triangles are congruent figures that are triangles. And what we know about congruent figures is that their corresponding parts are congruent, right? They have the same size and same shape. Corresponding angles being congruent, that determines the shape. Corresponding sides being the same lengths, that determines the size, okay? So that's the thing we can bank on, that we have some corresponding sides that are the same length, corresponding sides that are the same length, corresponding sides that are the same length, and angle A would be the same as angle C. Angle B is the same as angle D. In other words, congruent, right? Congruent. So congruent means equal, right? Equal measurements. Anyways, question here. Can we deduce that O is the midpoint of any segment? So now it's actually asking us to flex our sort of proving skills and establishing a fact here. Is O the midpoint of any segment? Explain. Well, if O were a midpoint, here's where I'd recommend really get into it and really marking up your diagram. If O were a midpoint of, say, segment AC, then AO would have to be congruent to OC. Maybe we'll get back to that a little bit later. Is it? Is it? Can you just justify that? And also, if O were to be a midpoint of segment BD, then OB would have to be congruent to BO right there, okay? And the two triangles are congruent. Okay, interesting. So they didn't actually give us the congruency, but what I'm looking at in terms of the congruency is probably this here. Triangle ABO, it looks like vertex A probably corresponds with vertex C. It looks like those two angles are congruent to one another, right? Will you buy that? Okay, so I'm going to make this C because C corresponds to A, and then B looks like it corresponds to D. Oops, should have put a D there. And O, of course, would correspond to the other O that we have here. So DOC corresponds to AOB. We don't need to put that. We just put O here. All right, so is O the midpoint of any segment? Explain. Well, I'm going to have to go with yes. Okay, so I'm going to go with yes here. Okay, because by CPCTC, right, we have congruent triangles, right, congruent triangles, and what we know about congruent triangles is that their parts, their corresponding parts are congruent. So because this triangle is congruent to that triangle, then we would know that this DO and BO would be congruent to each other. And check it out here. Look, well, we have this in the actual congruency itself. We have BO and we have DO right there, they're in the corresponding positions, the way we named the congruency. Right? We just visually saw that, but then I wrote the congruency out. That's enough to tell us that BO equals DO. So that means O is the midpoint of BD by definition of midpoint. So we got to kind of put that into words, and maybe I'll get rid of these segments things here so it doesn't throw us off. So for instance, O, because look at this here, these two are congruent. Okay, because CPCTC, because by CPCTC, let me get my reasoning here, OD equals OB. OB, right? They do because they're corresponding parts of congruent triangles, right? By corresponding parts of congruent triangles, we can establish that that length is the same as that length, right? Because these are congruent triangles, those sides are the same, okay? Therefore, what are we looking for? O is the midpoint of segment BD by definition of midpoint, right? Because that segment's congruent to that segment, that's enough to show that that point here is making congruent segments out of this segment BD. There we go. O is the midpoint of BD. Also, since, right, we can also prove this, that AO does equal OC because, look at this, AO and OC, they correspond too. So the segments connecting those two vertices, they would be congruent because they're corresponding in the actual triangle congruence here. The A appears first and the O appears last. The C appears first, the O appears last. That means AO and CO must be congruent because they're corresponding parts of congruent triangles. Also, since AO congruent to CO by CPCTC, or definition of congruent triangles, those are the same things there. By CPCTC, O is the midpoint of AC by definition of midpoint. All right. So a little bit of explaining, a little bit of wording that one out. I just want to show you how we can kind of word something out there. Email me if you have questions on that one. We're going to get some more practice with them too. 11 and 12, similar, kind of to defend your thinking, right? Defend your thinking type questions here. All right. If AB is perpendicular to BD, then you can deduce that line CD, if the segment CD is perpendicular to segment BD. Explain. The two triangles are congruent. Complete. Okay. So they remember this at the beginning here, they gave us that these two triangles were congruent. So let's check it out here. Congruent. Congruent, does that matter at all in this problem? I don't think it really does. Let's see here. Oh, actually it does. Yes, it does. Yes. So AB perpendicular to BD. Okay, if we knew this, let me do this in red. If we knew that AB is perpendicular to BD right there, can we deduce that CD is perpendicular to BD, right? If this is our given premise, this is perpendicular. Can we prove that CD is perpendicular to BD? Can we do it, and how? Well, remember, we were given that these triangles were congruent. Okay, these triangles were congruent. And because these two triangles congruent, we have corresponding parts, right, which would be angle B and angle D are congruent to each other. If that's a right angle, right, if that's perpendicular right angle, then that would also be a right angle, and then it'll also be perpendicular. Okay, so I sort of worded it out using words here, but let me go back to up top here. Look, B and D are corresponding in the congruence that we have for this one here. So that means that angle B is congruent to angle D. And if angle B is a right angle, because it would be through definition of perpendicular, then angle D would also be a right angle because they're congruent to one another. So all right angles are congruent to each other. So anyways, we got to kind of put that into words, and I'll try to do that with you along here. Okay, what did we start with? We started with knowing that if AB were perpendicular to BD, and we also started with these two triangles being congruent here. So what I want to say is, what I got to say first is that angle B and angle D are congruent. Okay, angle B congruent to angle D by CPCTC, right? They're congruent triangles, and these are corresponding parts of congruent triangles. Therefore, we know that they are congruent because corresponding parts of congruent triangles are congruent to each other, right? We just use that a lot to justify. That's how we can pick up information about triangles here. Angle B is congruent to angle D by CPCTC. And then we also got to say how we would know then that this and this, they would measure 90, right? So measure of angle B equals 90 by definition of right angle. And maybe change this to the measurement symbol here. So measure of angle B equals measure of angle D by CP/CTC, but measure of angle B equals 90 by definition of, definition of perpendicular, right? Because remember, a perpendicular, definition of perpendicular and right angle. Oh, God, sorry, guys, I might be confusing here because I know that you guys mess up every so often. Because these are perpendicular lines, we know through definition of perpendicular that angle B is a right angle. And then if it's a right angle, then we know it measures 90 degrees. So what I need to justify this with going from this step to going to it's 90 degrees is definition of perpendicular to get the fact that it's a right angle. And then I would use definition of right angle to establish why I know that this angle B is 90 degrees, okay? So if these are congruent to one another, which I have right here, the two angles are congruent, then by transitivity, measure of angle D equals 90 degrees by transitivity. And then finally, let's see, CD would be perpendicular to BD by definition. So this measure of angle D measures 90 degrees. It would be a right angle by definition of right angle. And we would know that the two lines would have to be perpendicular to one another by definition of perpendicular. So definition of right angle and definition of perpendicular. Okay, so kind of a lot of thinking here, almost like proofs you have to do at the beginning here. Wow, I think I said it would take about 15 minutes to do classroom exercises. Maybe it's going to take a little bit longer. For you, that is. It always takes me longer because I explain them. All right, suppose you don't know whether angle B and angle D are right angles. Can you deduce that AB is parallel to DC? Explain. Okay, so here we don't know whether angle B and angle D are right angles, but we want to establish that AB is parallel to DC, and we're going to see if we can do that. Well, remember, it was given to us that this triangle was congruent to that triangle, okay, congruent to that triangle. And the last problem, right, it was kind of given to you that these were right, this was a right angle. And if that's a right angle, this has to be a right angle, okay? Why did we know that? How do we know that they're right angles? Well, they look like alternate interior angles, but no, you don't know these are parallel yet. We want to prove that they're parallel, right? We want to get to establishing that they're parallel, okay? So we don't know if they're right angles, but we do know what, so let me undo this here. We do know that these would have to be congruent to one another by, look at that, by CP/CTC, because these right here, that one and that one, B, remember, B and D are corresponding angles of congruent triangles. So by CP/CTC, we know that they're congruent to one another. And if we know that this angle is congruent to that angle B is congruent to that, to angle D, we would know that these two lines, yeah, they'd have to be parallel because look, this is an alternate interior angle. An alternate interior angle. This is kind of, really have to get down into the diagram here. Look, this is the transversal, and this is one line, and this is another line. Boom, that angle congruent to that angle. Lots going on there. Let me break that one down for you for a second, okay? So because, right, what we're going to do here in explaining, we want to show that angle B is congruent to angle D, and that would have proved that the two lines were parallel, because if two lines cut by a transversal and alt interior angles are congruent, then lines parallel. Okay, so that's sort of the way we're going to get there. So we need to go through our thinking. How do we prove that? How did we get that there? Well, it was kind of given to us. Okay, right? Given to us. Let me just write the given back down here. We have that two triangles are shown are congruent. So we have triangle ABO congruent to triangle CDO. That was given. So then, right, we can determine that angle B, look at that, right? Because the B is there and C is there. Angle B and C, they correspond to one another in the congruency right here. So angle B is congruent to angle D, and that's by CP/CTC. Corresponding parts of congruent triangles are congruent. See why I wanted you to practice that so much? Because it comes up so much and you forget what it is. CPCTC, what is this? Anyways, keep practicing. Get to the bottom of it. Stay awakened, right? You're an awakened geometry thinker if you know what CPCTC is and you know how to use it in justifications. All right, angle B is congruent to angle D. We know that because they're corresponding parts of congruent triangles. They got to be congruent to one another. Definition of congruent triangles is also something you write down. Anyway, and this is going to get us to the fact that, right, AB must be parallel to DC. What I was trying to show you symbolically up there, I'll just write it back down again here. If two lines cut by a transversal and alternate exterior angles are congruent, then lines are parallel. Okay? All right, so you don't have any proofs on today's homework. So this is as close as you get to proofs here. So hopefully by going them with you, you got a chance to see. Let's just recap why you have these as problems. When you're given triangles that are congruent to one another, right, you can prove certain things through CPCTC. You can prove certain parts are congruent through CPCTC. That's the easy part, but then you can say other things, right? By saying that that segment is congruent to that segment, this point needs to be a midpoint of this larger segment. That segment congruent to that segment, this point must be a midpoint of this larger segment. That's why you're going to write so many proofs in this chapter here, because CPCTC gets you to make a lot of the other observations we've been practicing on here. CPCTC would get us, if this were a 90-degree angle, then that's a 90-degree angle because they're the same angles in congruent triangles. And so that means that they would also have to be perpendicular to those lines here, and then it'd be parallel, right? We don't ask a parallel thing here. Okay, anyway, CPCTC, angle B is congruent to angle D, and look, we have proven lines have to be parallel to one another down there. So interesting, when you put two congruent triangles on top of another like that, where you just have the extended side in the middle, those lines are always going to be parallel to one another. Interesting observation. All right, we're going to keep going here. We got number 21A, name the coordinates of a point G such that triangle ABC is congruent to triangle EFG. Okay, so this is similar to what was on your exit ticket yesterday. A lot of people answered this over here. You didn't notice how question number 20 was different. They were asking you what the coordinate of D was to get ABD congruent to ABC. Okay, so this was, you had to read this a little more closely here. So then they had this hanging out. Everybody's wondering what was this segment all about on yesterday's exit ticket? It had to do with the next problem in the textbook, problem number 21, which you have now. Okay, name the coordinates of a point G such that triangle ABC is congruent to triangle EFG. Okay, so what we notice here is that this is a length of 3. EF is a length of 3. And now we need to locate a point G that's going to get this side and this side, right, congruent to the two other remaining sides of a triangle up here, okay? So here, what I see here, I would do this. A lot of you guys are studying this in Algebra 1 right now, but it's slope, right? This is up to right 1, okay? If you know the Pythagorean theorem, you can figure out exactly how long that is, but I'm just saying it in terms of slope. But anyways, up 3 over 1, so, sorry, up 2 over 1, so it looks like that's what we're gonna have to do. And here, going from B to C, we're gonna go left 2 and up 2. Okay, so we're just going to do that over here, and I think it'll work out. This is a side length of 3, so we're going to go 1 unit over and 2 units up. Boom. There we go. Locate name the coordinates of a point G. So that's G right there, such that triangle ABC and EFGs. Okay, so here AB and EF relate. That's right. AB and EF are good to go. Now we need to make sure that EG is the same length. Color. Okay, and I think it is up over 1, up 2. Yep, these are the same ones. Those are definitely congruent. And finally, GF. Okay, GF I'm just going to draw in, and yeah, this matches here, right? Over 2, up 2, and we're good to go. So those are congruent as well. And here, right, this was given to us. This was already congruent. Those two triangles look congruent to me, right? The rest of the angles look congruent. Interesting. We just know that the sides are congruent, but hey, the angles are also congruent here through observation, and that'll be an assumption we make next section here. All right, we found a location G, so I guess our answer is here is this. Yes, and I'm going to go with 6, 5. A lot of people were putting that in their exit ticket yesterday, so read the problem carefully, right? Read the problem carefully, and we got that here. And it says here, name 2 other locations for a third vertex in the coordinates of point G, such that. Anyways, sorry, keep reading here. Name 2 other locations for a third vertex for a triangle congruent to triangle ABC that has EF as one of its sides. Ooh, two other locations. Interesting. Okay, so we already have up here at x is 6, y is 5. There's 1 point here. But you may have noticed this here too. Check this out. In two other locations for a third vertex for a triangle congruent to triangle ABC that has EF as one of its sides. Okay, so here we went up 2 over 1, and that sort of gave this length here. What if we go from here, we go down 2 over 1? Right? Wouldn't that work out? Isn't that the same length? Yeah, down 2 over 1. That's the same as going up 2 over 1. That'll lead to the same length. Remember, distance doesn't matter if it's positive or negative. Distance is always positive. So here, we would call this the same distance as that distance. And then here, this is up 2 over 2. That's the same as going, I guess, we're going from B to C. If we're thinking C to B right here, we're going right 2 and then down 2. Anyways, these would end up being the same. Okay, so there we go. Boom, 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 boom. Okay, so 6, 1. Looks like one of them. And they say another one here. So this one, if this were G here, then triangle ABC would be congruent to triangle EFG. It looks like it may be talking about another triangle here. But hey, if we just reflected this one, let's just reflect this one real quick. Actually, I'll do it up here. How about this? Is this triangle here? Is this triangle here congruent to that triangle? Notice here, they don't mention the name of any coordinate, or they don't say what the congruency is. They just want to get one triangle congruent to another triangle. So if this were H right here, then this would correspond as EFH is congruent to BAC, it's congruent to BAC. So anyways, they don't care about you writing out the congruence, but this one will get you the answer here. Okay, so this is one of your answers, 7, 5. Would be another answer, okay, would be another answer. But we would have a third answer too that we haven't talked about, and that's down here. So might as well put this one down in case you guys get this one. If you had to ask, is this triangle also congruent to that one? Well, it doesn't really look like a line the way that I drew that. You like that a little, make it straighten out. There we go. Yeah, that triangle would also be congruent. Okay, so 7, 1 is also acceptable, right? That triangle would be congruent to that triangle here. So notice, when you do a reflection, when you reflect a figure, you still result. The result is still the same size and the same shape, okay? Side lengths are all identical, all congruent, and the angles, right? Angles. This angle here is congruent to that angle here. Look, they're the same. These angles here, congruent to these angles here. This angle here, congruent to this angle here, and so on and so forth. And there you have it, okay? There are the classroom exercises. Written exercises, what you guys have here, what you all have for here is making some observations, basically. I know that it says it would love for you to have a protractor, but I've never required you to get a protractor, so don't worry about that. Just try to estimate it and try to do this as accurately as possible. This one here, this written exercise, it says accurately draw the pairs of triangles described. Measure all the corresponding parts of each pair. Are the two triangles congruent, okay? So how many corresponding parts are there of a triangle? So it says measure all of the corresponding parts of each pair. And so that would mean 6 parts, right? 3 corresponding angles and 3 corresponding sides, okay? So it's asking you to do this here where it's actually only giving you right now, it's giving you 2 sides and 1 angle. 2 sides and 1 angle. It's asking you, can you draw a triangle given this side length, that angle, and then another triangle given that side length, that angle, and then this side length? And then would they have to be congruent, or do we need to be told all 6 parts need to be congruent? So anyways, maybe we'll observe it first, and then we'll kind of think about why this is a question in a second. This is triangle ABC. We're going to try to go AB is 4 centimeters, BC is 6 centimeters, and we have an angle of 45 degrees. Okay, I'm going to draw AB right first. So you don't need to do the 4 centimeters necessarily. Remember, units of measure are just kind of arbitrary. They're human beings came up with units of measure. So here, just use your grid paper. Right? Use your grid paper to figure this out, and you'll be fine. So I'm just going to go 4 units for segment AB. So let's check this one out. We got segment A, 1, 2, 3, 4. B. This is segment AB. Okay, there we go. All right, what's next here? It says measure of angle B is 45 degrees. Okay, so that means I'm going to go like this. So a 45-degree angle, remember, this is a 90-degree angle, 90-degree angle. This is a 180-degree angle, okay? So a 180-degree angle, half of 180 degrees is 90 degrees, okay, is 90 degrees. And then half of 90 degrees is 45 degrees, okay? So this is how you draw a 45-degree angle. You draw it diagonally across the grid, okay? There we go. There's your 45-degree angle, right? You see that there? I'm going through the lattice points, right? So my slope here is, well, -1 on this one, but yeah, there we go. So you don't need a protractor on this one here. This would be a 45-degree angle because it's half of a right angle. Looks like I got it a little bit off here. Let's try it again. There we go. Okay, so this is 45 degrees. And now it wants to do BC, so I got to measure off 6 centimeters. Ooh, that's kind of tough. That's kind of tough the way that I have it here. So that's a little tough because I don't have a ruler with me. This actually is a little bit harder here because I got to know Pythagorean theorem to do 6 centimeters, okay? This is 4 centimeters. Okay, this is 4 centimeters. So 6 centimeters, oh man, this is a little bit tough here. I gotta like slide this. Okay, let's pretend we have a compass right here. That's about 4 centimeters. Let's go 2 more. Eyeball it, okay? Eyeball it, whatever. It's all good. All right, so here, we'll say that this is 6 centimeters. This is 4 centimeters. And it doesn't give us anything else, so we need another side, right? This is C. Oops. And there's our triangle. That's the only way we can draw a triangle, given a side length, an angle, and a side length like this. Now let's do another one here. Maybe I'll do the 6 centimeters down here so we see it a little bit differently. I'll do the 6 centimeters down here. 1, 2, 3, 4, 5, 6. It didn't work out too well. One, 2, 3, 4, 5, 6. Okay, and this is EF. And E is the 45-degree angle, so let's do that here. And I'm going to go 4. Be a little over 3, right? This looks like about the same length. And then here. And then let's go to EF right here. Oops. Okay. We knew that this is a 45-degree angle because I drew it kind of on the diagonal, right? Half of a 90-degree angle would be a 45-degree angle. This here is your 6 centimeters. This here is roughly your 4 centimeter one right here, okay, 4 centimeters. Okay, so what is given to us is this. This side congruent to that side. This side congruent to that side. This angle congruent to this angle. I don't know why I did 2 tick marks there. So then the question is, right, then the question is, this angle, is that congruent to this angle? Okay, look at this here. It's a little bit obtuse. This one here, also a little bit obtuse. And it turns out if you actually had a protractor, those would actually be congruent right here. This angle right here, I drew this a little over 4 centimeters, I think. Oh, God, I wish I had a ruler to actually do this out. But I don't have a ruler. That's fine. Anyway, and then this angle here actually would be the same. So anyways, the point of this one, and maybe when you do this one, is that if you were given a side congruent to another side and then an angle in between another congruent side, and those 2 angles are congruent too, that's enough actually to tell that the triangles would have to be congruent. We're going to get to that. That'll be a postulate next chapter here. So here, EF, what is this? EFD. Okay, so D and A are congruent, right? D and A are congruent right here. Those are the 2 obtuse angles. There's a C and F, right? And I didn't draw these perfectly, but they should be congruent, and yada, yada, yada. Are the 2 triangles congruent? So yes, the 2 triangles are congruent. It'd be a lot easier if I had a ruler. It would look much more clearly congruent. Anyways, let's see if I can get this one to look congruent, because these ones should be congruent. So I'm going to put that one here. Yes, they are congruent. And let's check this one out. Triangle RST, if measuring angle R is 30 degrees, measuring angle 5 is measuring angle RS, sorry, distance RS is 5 centimeters, and measuring angle S is 100 degrees. Let's just give this one a shot and see if this one works out. So let's draw the segment first. That's 5 centimeters, so I'm going to do this. I'm going to go 1, 2, 3, 4, 5. Okay, and that's RS. Measuring R is 30 degrees. So here, that would be, if this were 90, we'd have to divide it by 3. So not, this is 45 right here. So this would probably be about 30 degrees. So just estimate it. I know if you had a protractor, all right, we'll get tools to get this a little bit better. So there's about 30-degree angle. Okay, a little less than 45, right? 45 would be a little further. Right, 45 would be here, so it's a little bit above half this, right? 45 would be right along the diagonal. So this is about a 30-degree angle. So let's go 30-degree angle right here. Okay, and then measuring angle S is 100 degrees. So that's a little bit more than a right angle, right? This is a right angle right here. So let's just go a tad bit more. And boom, there you have it. Okay, so this looks like the triangle right here. This is 100 degrees. And this would have to be T, point T. Okay, and then the question is, right, we were given this. This was 5 centimeters, 30 degrees, 100. Oh, sorry, that's not 100 degrees there. This is 100 degrees is down here. Okay, given to us like this here. Let's draw the other one, triangle XYZ. And I'm going to draw it to look a little bit different, just to so we get used to like seeing congruent triangles drawn a little differently. I'm going to do it where I'm going to draw the third vertex below this. So I'm going to go 1, 2, 3, 4, 5, and let's make this X, Y, and I'm going to do Z down here somewhere. Okay, I'm going to do here down here somewhere. So X is 30 degrees. So again, this is 45 degrees. I'm going to do a little bit less than that. It's about 30 degrees, I'd say. Okay, this is our 30-degree angle. Okay, and then angle Y is 100 degrees. It looks like here. I'm gonna do a 100-degree angle. So this would be 90 if I just went vertically down like this. So if I do this, this is more like 100 degrees. And there you have it. Okay, and look at those triangles. Let's take a look at them. These ones might look a little bit more congruent than the last ones did, even though the last one should have been congruent if we did that experiment. So we have this triangle right here, and we have this triangle right here. What do they look like? Do they look like they're the same size and same shape? Well, ideally, you have a protractor, you have ruler and stuff like that. You can actually verify this in your own. But yes, those look pretty darn alike here. So we definitely know what was given to us was we had an angle congruent to another angle, and we had another angle congruent to another angle, and we were given that that side length was congruent to this side length because this is the 5 centimeters one. So we already know that those 3 corresponding parts are congruent. Let's look at RT. Does it look like it's the same as XZ? Okay, XZ corresponds to RT. And yeah, right, they're both the longest here. They look, if we had a ruler, we'd hopefully notice, yes, that these are the same length. And also YZ and TS, those look pretty darn identical. Okay, if we had a ruler, hopefully be able to observe that those are congruent too. Okay, so this will be a postulate, actually, a postulate next lesson we have on Thursday, that if you're given an angle, a side, and an angle, angle, side, and another angle that are consecutive like that, right, where the side is in between the 2 other angles here, and they're congruent to an angle, a side, and an angle in another triangle, in 2 triangles, you're given this information, then we can conclude that the 2 triangles are congruent. So it's kind of something called a triangle congruency shortcut is what this problem is getting at here. Look, angle T, that's got to be, right? That's got to be. Actually, if you have 2 triangles and 2 of the angles in one triangle are congruent to 2 of the angles in another triangle, then the third angles are congruent. This would actually be a 50-degree angle right here. So it would definitely be congruent to one another because you take 50 away from, you take 30 and 100 away from 180, you're left with 50 degrees, right? So these 50-degree angles, so those are definitely congruent. And that's that. The 2 triangles are congruent. Yes, they are congruent, and we previewed something that'll come up in section 3.2, which is triangle congruency shortcuts. All right, folks, that was a long video. I'm guessing nobody watched the whole thing, but at least have some problems out for you. So when we go over these, if you're like, I didn't get them, I could be like, oh, check out the video. Check out the video to go through them. So just quick scroll through. Hopefully you get all this, and we can get into some more interesting stuff in section 3.2 on Thursday. You'll have an asynchronous lesson that day. I already have it filmed, and we'll just do an exit ticket. And that'll be Thursday. And then Friday, that's when you do your problem set over the weekend. Email me if you have any questions. Take care, guys. Bye.